Okay. Guys, I'm going to go through this one very fast. You've done this, so we're just marking it. Hey, now it's over. Come on, come. I'm screaming in the video's ears. I'm not. I'm recording it, so you can see it later if he wants to. Okay, this is the one that you guys did, right? So they gave us information about the electrons. So I think all of you started with Q equals IT. So you said I is 0.5 times by the time, which is 30 times by 60. That gave you a Q value of 900. Coulombs, nice. And then you have to use Q equals NF because we need to get the number of electron moles. Remember, this is how we get to electron moles. If you use the equations with Q, it's all about the electrons. So Q then is the 900. Hello. He's there. Okay. All right, he's there, guys. So you don't know. You can stop stressing about him. What? N 96,500. Yeah, I think so. Yeah. Okay, 900 times by F, and then it gives us a value for N. What did you guys get? This is the best way of writing it. Please remember that it is the best way to write in scientific notation because then you're not rounding off too much too early. Or leave it as a fraction. So that is still fine. We're just marking the one you did yesterday. So we're just going to do the rest of them? No, we'll do one you, one me, because I really don't want to spend more than today on this with your class. But they asked us for the volume of oxygen. So the next thing you need to do is remember to climb from this side to this side. We need the ratio. So the ratio is electrons to O2 because we've just worked out electrons. If you look at your balanced equation, it was 4 to 1, so you had to divide by 4. So you took this value and divided by 4, which gave us the moles of O2 as, what did you get for this one, Carly? 0.23. Okay, like I said yesterday, don't round off too early because if you rounded this off to what the paper tells you, you're going to get naught. So please don't ever do that. Then rather use the scientific notation. So this is the moles we get, and then we need to get to the volume of oxygen. What equation did you use, Nelly? I know you did it though. N is equal to V over Vm, and you know that Vm is 22.4, and you got an answer for the volume, so the moles there is what you used. You got an answer of 0.5. I think you all got it right, 0.5 decimeters cubed. Okay. Did you two get it right as well? Nice. Okay, so that method in your book on page 635. Did you see it? Scratch it out with a neat line if you want to, Sam. Is it not 0.5? Oh, sorry, 0.05. Okay, now, guys, please remember that method there is going to confuse you. This is the method that we are going to use. Welcome back. We just marked the question, but you got it right yesterday. All right. This one is a little bit more tricky. I'm going to do you one, me one. That was yours, so this one's mine. Hi. It's okay. Sure. Okay, so this one's mine. They tell you but please think with me. Make sure that you understand what we are. I mean, by mine, I mean we're doing it together. No, here on the board is where your eyes should be. Out of your way. A student conducted an experiment to calculate the value of Faraday's constant. When this person is calculating the value of Faraday's constant, can you use F on your information sheet? No, please remember that. So an electric current was passed through the solution, so they're giving us a current, so we know we have that, of copper sulfate for 40 minutes, so they're giving us the time as well. They're telling us that the mass of copper that formed is 0.240 at the cathode. Use this information to calculate it. So can I this time start with the current in the can I start with getting moles of electrons? Although I have the current in the time, I can't work out the moles of electrons because I already know what was formed. Whenever you get the mass of the chemicals, it's 99% of the time that's where you're going to start. Yeah. So this time they're asking us for F. So you are going to end up using the equation Q equals NF. You need to end up using it because you need to figure out what F is. All right. So where do you think I'm going to start? To get? We can do that. Let's do that. You might, and then we might get stuck at some point. So we're going to say Q equals IT. Please just start. Don't think, oh, this is a weird question, I'm not going to do it. You know, if you get a question like this, you can start using Q as IT. So you guys are already there. So the current is 0.3 and it's done for 40 minutes. Can I use 40 minutes? So it's 40 times 60 again. Now that I have my calculator back, but please calculate it for us. Sure. Is it? Say again? Thank you. So 720 coulomb. Thank you. Yes. 720. What's the next step? Okay, so let's see. Q equals N F. Okay, can I use this? I have Q, but do I have N? I don't have N and I don't have F because I'm not allowed to use it. Okay, so I'm stuck. So as soon as you get stuck, you go to the other side. It's almost like, I want to say it's like Newton, but I don't know if you guys will see the connection. I think everything is like physics. So how am I going to get the moles? N is M over big M. They've given us that it was 0.24 grams of copper. On your information sheet, tell me what the molar mass is for copper. 63.5. And you work out your moles. But remember, always tell them, this is the moles of copper. Relative molecular mass. N of copper is then that. What do you get? Don't you like scientific notation? Much better. Anyway, guys, that's an ugly number. It's much prettier if you write 3.775 times by 10 to the minus 1, 2, 3. The calculator does it for you. Isn't it 4? Oh, is it? So it's not 5, it's 9. Okay. All right. Now, you have the moles. Because you didn't have to do both. One on one is fine. You can even leave it in the fraction form for this if you wanted to. This is the moles of copper. The moles in this equation, what is it? That N. Electrons. You will never use a Q equation and for chemicals. It's always going to be for the electrons. So now, what's my next step? Ratio, nice. So to get my ratio, I now have my copper, so it's going to be copper to electrons. Where do you get this ratio from? Okay, so tell me what it is. Forms? Cu. So what's the ratio of Cu to electrons? 1 to 2. So now I can get my moles of electrons. So all you have to do is times by 2, and that gives you 0.00. You've got the final one. What's 37 times 2? Did you now do scientific notation? Okay, tell me, Nelly. Okay, so now we have our moles of electrons. Can we now get F? Yes, because here I can, instead of this Q, I can write my 720 that I worked out just now. Instead of the N, I can write my moles that I've just worked out. 7.559 times 10 to the minus 3 times by F. And now your only job is to go and get F. What is going on with you?
I'm hungry.
And what do you get the, Shamiso, what do you get the answer? Do you get the same as James? What is this unit, guys? No. Thank you. It's even on the information sheet, Coulomb per mole. So now, guys, this is a very, very nice question for percentage accuracy. How accurate do you think this guy is? Okay, so if you're going to do that, please remember it's always easier to get your percentage uncertainty first. So he's wrong by how much? So you need to then say, to get the percentage error, or you can call it percentage error if you want, you're going to say, okay, he got this value, he should have got the 96,500. He got 95250. So you get the difference between those values, always positive. And you divide it by what he was supposed to get, 96,500. And you times it by 100. Because this is the type of thing that can pop up in any question. This can be in any question in chemistry, percentage uncertainty. So what did anyone calculate it? Bianca, what do you get?
98.
Really?
78.
Oh, did you minus them from each other? Yeah, so you didn't. Bianca, what's your answer?
1,295.
1,295% is the uncertainty, is the error. So what is the certainty? So you're just going to say 100 minus that, and that's where you got your 98. So the percentage error is this, percentage accuracy will then be 98 point, whatever that
Why would
is.
you work out percentage error?
Because you guys sometimes get more than 100 and then you think it's okay. Because if you didn't, if this value was bigger than the value that you were supposed to get, then you're going to get over 100. Can you be over 100% accurate? So as long as you realize then that it's impossible and you fix, that's fine. But often people leave the answer as bigger than 100. You can't ever be more than 100% sure. So that's why I always say it's better to get your error first, and this is what they're going to teach you at varsity anyway. It's a good method to learn now. So you're going to get your uncertainty first. How big is my error? And you minus it from 100, and that is your certainty, or the accuracy.
So if it was bigger, we just take a bigger volume.
Yeah, so you can always say it's the absolute value here. Do you do that in math still?
You do have an 18.
Oh, sorry. Say again, James? Yeah? No, this is the this 96,500 is the constant that has been determined during thousands of experiments. So we were going to believe this value. So this value that he calculated is pretty correct because it's 98% fine. If it's within 10%, you think you've done an amazing experiment. So that's what they also teach you is that if it's, the uncertainty is smaller than 10%, you're super happy because you got the right answer. No. Our answer is only 98% accurate. Yes, that's true. You guys, I want to skip to F because I'm not going to do all of these in class. F is the other way around. They're very similar, all of them now. If you look at C, determine the mass of gold that would be plated onto a ring using gold nitrate. The current is that, the time is that. Can you see it the same question? So can we skip this one? Okay, you can go and do it for fun later. This one tells you that we've got 500 cubic centimeters of sulfur hydroxide to produce sulfur. Determine the mass of sulfur formed and how long did this process take. So this one's a little bit different, right?
Right.
Go for it.
And so how much they really ask on the numbers? Like, determining the oxid, what are they called? Those numbers, the table. What's it called?
The voltages, the potential.
The oxidation number. How much did I use in this section? Like this? Not much.
That's why we did it very quickly last year.
So it's very important.
Well, you can use it to determine if something is oxidized or reduced, but now you have the table. So you can also use the table to do that.
But like, they're going to also use the oxidation number.
I've never seen it in a matric paper.
So this is basically uses.
What is uses?
The oxidation.
Yeah, but not this. This is super important.
Yeah.
Yeah, the oxidation numbers is just to introduce basically the topic to you.
So what I'm saying is, you promise.
James? Okay.
Yeah. What did you get?
Oh, you do it yourself.
What's the aim?
He said, that's something like it.
What did this question not tell us that we are assuming? Please remember that when we ask you this in exam, You need to tell you that. Or assume that if it wasn't said.
This is history.
Does anyone need help?
Options. The final answer, 86.
That's how you know. Are you done, Timmy? Did you get that?
86,161. Get it.
Oh, they wanted time. 50 ampere, yo. That's huge.
Is it 10, bro? No 10.
I just posted you. It's a just tell me if it's a second or hours. What is it?
Seconds. But that's not the volume.
What? What did you guys get?
0.8. What? 80. 0.8, I was 16. Yeah, but then.
How, guys? 0.04.
I don't know.
6. I don't really.
I got that too.
Okay, that's fine. But remember, once you've written a value down, you need to use it.
If I still run up.
No. Then you want to say, how does she say 8?
You understand it though? No.
Is that the rounding area?
No.
Yeah.
Still 4 the same cases.
When are we going to have our
How
day?
many did you use?
I just
Which other day works?
on my book.
Can you come
Like
tomorrow?
I didn't press here.
Oh.
For English.
Yeah. But still rounding it. That's not like my definition.
You can't do it any mornings. Monday I can't do straight after school because I'm actually going to move the ASP because we've got the grade 11 and 10s who were not at school this week. They're writing tests on Monday. So we can do Tuesday or week or Thursday.
I'm saying.
But we need to do it. So you don't understand this. But we didn't tell you yesterday. Okay, let's go through it quickly. Guys, let's just go through it quickly, please. Everyone back to your seats. Come, let's follow the procedure that we used. There was a normal stoichiometry question mixed. Come on, Timmy, come. Where are you going?
Sentinel.
Huh?
Sentinel.
Oh. In the middle of a lesson, it's a bit odd. Is there nothing in my thing?
Yeah.
Okay, so first question is just asking for the mass of sulfur. So that's the old type of quantitative question. Please remember that that is actually the biggest topic in your chemistry exam, but there's going to be no question on it. It's inside all the other questions. There's no question on stoichiometry, but it's the biggest percentage. So please look out for it. Keep on.
You lose marks for rounding.
No, I said it earlier. It doesn't matter if your answer is not exactly the same as mine. It depends whether you keep the value in your calculator or you don't. If you wrote a value down, you should be using that value that you wrote down. Thando, back. We're going to break the
No, I'm talking about like in the final paper. So we get like 0.8 off.
No, it doesn't matter. They always have the two answers. The answer for you keeping the value in your calculator or the answer when you're using your values written down. All right. So, guys, follow the procedure. So, the first thing you needed to figure out is which equation do we need from the redox table. So, you're always going to read the question, what are we forming? They say we're using hydrogen sulfide, which is H2S, and we are producing sulfur. So, did you all agree that this was the equation that we need to use?
Yes.
I'm hearing that? Okay, so that's the equation. For the first question, it didn't involve electrons. It was chemicals. So they said how much sulfur was formed. So we needed this equation. They gave us the volume of the H2S. Because they gave us the volume, we can use N as V over Vm. Please listen. V over Vm. They've given us the volume. Why did I use 0.5 here? Because I'm not allowed to use centimeters cubed, I would use decimeters cubed. Please don't forget that in an exam. So you divide by 1,000. Divide it by your 22.4 and I got 0.02232. Are you all with me up to there? Okay, then the ratio of H2S to sulfur is 1 to 1. So they gave us an easy one because there it's 1 to 1. So that means the moles of sulfur is the same as the moles of H2S. Did you all agree with that? Did you at least think about the ratio? Don't just ignore the ratio. So there, that brought us for question 1, we now have the moles of sulfur. So we're going to use our old equation, N is M over M, to get the mass of sulfur. Is this first part relatively easy? Rose? First part's easy. Okay. Now for number 2, it says, how long did this process take? So what are they asking for? Time. So you need to realize that the formula you're going to use for time is Q equals IT. So we want the time, we have the current, but we don't have Q. So that is why we needed the moles of the electrons, so that it can give us Q, so that we can stick Q into that equation. Does that process make sense? So that is what I did on the next page. You didn't need the mass, you just need the moles, because we're not really interested in the mass. Because the ratio that we're now going to use is the ratio of sulfur to electrons, and that is 1 to 2. And we have these moles is 0.0232, or you can leave it as a fraction. So then you just have to times that by 2, which is 0.04464. Are you with me now, Rose? Okay. Now we have the moles of electrons. And remember, in a Q equation, we could only use the moles of electrons. So what I did then is for this equation, Q equals N times F, I was lazy to do it twice. Because Q is N times F and Q is IT, we can actually say that NF is IT. You can do that as well in the exam. You can do it in 2 steps as well. We have these moles because we worked it out with our ratio. Times by Faraday's constant, we have the current is 50. Please note that 50 amperes is a high current. There's no ways I can produce this in the lab. That will kill you. Okay, so that is why also this industry is expensive, because the currents that we need is super high. And then you did the maths, we did the maths, and we got the time. So if you get stuck, just start with some form of equation. Just start. And the two should lead you to each other. Do you still have a Lucy? What name is in your book? Is it Lucy? I thought I changed the name, so obviously. Oh no, but you got these books last year. What are you saying, James? James is deciding you guys only have 2 minutes. Oh, we really would like you to do... We're not working tomorrow because we're doing the pracs. So please, if you guys can just do E for Monday, just the one. Just so that I can see you're okay with it. Because then we're going to do spontaneous after that. I guess I can stop this recording.